Hello, my name is Chris Claydon and I'm the Chief Executive of the Engineering Construction Industry Training Board. It's a real pleasure to be taking part in this session today and bring to you the ECITB's perspective. For those of you who don't know about us, and I'm assuming there are quite a few who may not, we're the statutory skills body for the engineering construction industry in Great Britain. We're an employer-led organisation and our prime purpose is to meet the skills needs of the industry. Our work helps to drive productivity by supporting employers to train and upskill their workforce to industry standards, as well as delivering productivity enhancing initiatives such as connected competence, which I'm going to speak about in a little bit more detail later on. As you can see from the slide, we cover 8 major sectors, with oil and gas being the single biggest sector that we deal with. So in this session, I'm going to talk about meeting the energy transition challenge, and as part of that, look at one of the projects, an Aberdeen-based project we're engaged in to help do that, which is called Connected Competence. At this point, I'm now going to switch off my camera because I suspect I'm going to become more of a distraction in the way I'm moving around, and it won't enhance your enjoyment of the slides. To achieve net zero by 2050, all parts of the economy must decarbonise. The industrial sectors account for 21% of UK emissions, yet it's so far received far less attention than transport and energy. We must also go further to reduce emissions in the energy sector, and this will be a combination of decreasing demand where possible, by increasing production efficiency, and by reducing direct emission through fuel switching and carbon capture. Decarbonisation of heavy industry and energy systems depends on a number of factors, including the ability to deploy technologies such as carbon capture and storage and hydrogen at scale, increasing the UK's capacity in offshore and onshore wind, policy levers to attract investment, and a supply chain ready and capable of delivering low carbon projects. And thankfully, that aspect, the supply chain, already has many of the skills and the expertise needed. Indeed, engineering construction companies, the process engineering supply chain, has significant experience both in the UK and globally in designing, project managing and delivering industrial scale projects. And they're already playing their part in net zero by building clean energy generation capacity in onshore and offshore wind, nuclear, waste to energy and other renewable technologies. As we know, the simultaneous economic pressure of an oil price depression and COVID-19, which has further exacerbated it, is likely to see a significant skills outflow across the economy in the next 12 to 24 months. An estimate suggests that 30,000 workers could be lost from oil and gas alone, a fifth of the workforce. By comparison, the industrial clusters could require upwards of 30,000 workers. Teesside cluster suggested it alone will need 5,500 workers at the construction phase. And if all of the 6 industrial clusters plan to mobilise simultaneously, the demand for skills will be significant. This, we think, presents a real opportunity to transfer skills from across the industry, but particularly from oil and gas, into delivering our net zero commitments. And in fact, we'd go further to say that actually the oil and gas workforce is vital to the delivery of net zero. The time lag, however, is the crux of the problem. There is a major risk that the skills that the industry currently has or would ordinarily be recruiting will not be there by the time the energy transition projects are at a shovel-ready stage, leading to a skills shortage. At an occupational level, our research shows there is good skills alignment between existing engineering construction industry skills and those required for low and zero carbon industrial projects. I mean, there are some notable exceptions. Technology is a growing focus for the delivery of net zero, and we'll need data analysts to monitor things such as CO2 storage and transportation systems for leakage. Also, systems thinking will be a critical discipline and is central to achieving a circular economy. For example, how are we going to integrate a CCGT plant, hydrogen reformulation technologies, CCUS and waste to energy? However, earlier this year we published a report on the implications of the transition And the slide you can see now on hydrogen technologies is one of the snapshots from the report, and it shows the different stages of hydrogen along with the key technology components. But interesting is the columns 4 and 5, the time frame and the skills impact. And it's quite clear that many of the skills currently exist or can be brought up to speed in a relatively short period of time. So what's going to be key here is transferability of skills. It's going to be absolutely vital. We published some research this month called Skills Transferability in the Engineering and Construction Industry, which sheds light on the similarities in skills and competencies of engineers in the many sectors that support Britain's energy and processing infrastructure, from renewables to oil and gas, nuclear and pharma. It also identifies barriers to skills transferability, such as ingrained workplace attitudes and recruitment practices that compartmentalise trades and occupations unnecessarily and place unhelpful restrictions on the mobility of workers. And there are a number of initiatives that we're involved in and undertaking to improve that transferability issue. But I intend to highlight one here, which has also moved to adopt a digital approach and is based in Aberdeen: Connected Competence. Connected Competence is a collaborative project between the ECITB and the major tier 1 contractors within upstream oil and gas to standardise and assure competence requirements for the workforce. Under the programme, workers undertake assessments designed to prove ongoing technical competence. By passing the tests, they're able to demonstrate that they have their necessary craft or technical skills recognised through a standard model. And the benefits of a competency passport are numerous, not least in helping to mobilise skilled workers for the projects that need them, and helping to build a more resilient, mobile and sustainable contractor workforce. It also supports the transfer of workers to other energy sectors when they're required, thereby helping to retain skills within the wider engineering and construction industries. This project came out of trying to address the competence challenges in the sector, which are shown on this slide, which effectively summarises the situation as it is now. You know, we all come across this situation where contractor A has a different set of requirements for an electrical technician than contractor B, and from contractor C, who has got yet a different set of requirements. So nobody is transferable. And for someone to move between employers to do jobs on different platforms becomes a very costly and resource intensive exercise. And this is within the sector. Trying to get the skills transferred between sectors is even more of a challenge. So the heads of the tier 1 companies got together. We discussed the challenges and we tried to identify what success looks like. And this slide really summarises that. You know, that we want a consistent operator mandated approach to technical competence, an assured baseline. That connected competence enables people and skills transfer across sectors, supporting the key aims of Roadmap 2035 and HSE's Offshore Energy Sector Plan. The competence is assured at the individual's places of work or at an onshore testing facility and accepted throughout the industry. There's a level playing field, both technically and commercially. Everyone does competence the same way. Duplicate and unnecessary training is eliminated by suppliers, contractors and operators. And then digital technologies enhance the transparency, the speed, the quality and cost effectiveness of competence assurance. And the model that was developed to deliver against those criteria has 5 pillars to it. The first is on making sure that things are standardized. Industry role profiles set the expectations, qualifications, pre-mobilization, competence requirements. These are generic across industry based on NOS. The second pillar, that they're transferable. The base standard is easy to identify and can be applied to organizations' existing technical competence management systems. So the transferability element is identified and then recognized through digital badges. The third pillar really is about being informed. It's the standards are relevant to current working practices and sequentially aligned to common work scopes to maximise efficiencies. The fourth pillar is making sure everything is accessible and the training and the competence assessments are accessible. So there's on-site, off-site through digital, remote or via approved test centres across the UK, delivered via standard ECITB testing route or using existing employers' procedures to assure competence. And finally, that it's recognised workers are responsible for their own ongoing competence, demonstrated through qualification and digital badges, with the engineering and construction sectors recognising transferable standards as a minimum requirement. When we first set out this programme, it was planned that testing would take place primarily at onshore establishments, using test centres close to where the workers live to reduce costs and minimise the loss of productivity and time away from home for the workers, which was an equal consideration. And that approach has been adopted and is working. However, we've now set about delivering it in a more cost-effective way by some advances and some use of digital assessment, which can be done at work on the job. This important development has come about really, again, industry-led, seeing what's being done on the platforms and looking to see how we can enhance the offering of connected competence using much more up-to-date approaches to it. So the technical tests, as I said, are based on NOS. The test activity is within existing work scopes, and I think that's really important, so that they're being tested or assessed really at work doing their normal day-to-day jobs. And it's using intrinsically safe tablet and headset to capture the video evidence and assure the test compliance. And that is, of course, is recorded and then can be reviewed as necessary. Very simple equipment, relatively cheap to get hold of, and really has. We started to use it, and it's starting to prove effective. We think the value proposition that comes out of this are efficient standardization and transferability of skills. We certainly can see the increased productivity, that you've got a competent, safe workforce working to a common set of standards, and this can be done, and the assessments, all this can be done in work without having to spend time away. There's the COVID-19 issue. I mean, it helps to minimize that risk. The cost efficiencies are really clear. And as I mentioned earlier, it can be recorded, it's auditable, it's evidenced. And I think that should give a sense of confidence to all involved in the process. And it enhances the well-being of the workers, and it's to their advantage as well. So we're currently running a pilot, a digital technical assessment pilot, trying this out. Phase 1 is to deliver the on-site digital technical assessment test, the standardization part. We're doing it on a range of platforms at the moment, on Anasuria, Barrow Onshore Terminal, Sage, Balmoral, Albanorth, Judy and Morecambe Bay. The sourced equipment is GDPR compliant. It's training is simple and provided on the equipment. We have a collaborative IT platform shared amongst the contractors, generously supported by Petrofac predominantly. We've agreed work scopes and ease of access. And the tests are coming in now. We've been practicing with them, and we're building up the evidence base of successful completion of those tests and how they can be done. The second phase, which is running concurrently, is really trying to look at the transferability element here and ensuring that we've developed the taxonomy, so producer mapping, taxonomy and structure to enable all the organisations to identify the connected competence-based standard and therefore identify a gap analysis. And finally, phase 3 is asset transferability, where we have enlisted 2 oil and gas operators to identify and compare where the connected competence-based standard aligns to site-specific competencies. Total and Cresor are supporting us in this. So I see I'm pretty much out of time, so I shall skip through the forward plan and just really make 3 remarks in conclusion. Transferability of the workforce will be key to meeting the needs of net zero and energy transition. We need to act quickly and we need to act collaboratively. And we believe that connected competence is a methodology for doing that, which is available across the engineering construction industry. So thank you very much, and I look forward to questions later.